Hi everyone, it's Ahmet here. Today I'm going to solve some problems from Karekök book. It's Turkish publication, but the questions are in English, so therefore the video will be in English. And the questions will be the challenging questions, challenging part of the book. So they are miscellaneous questions. And the polygon part, I'm going to solve the polygon part, okay? So there are 10 tests about them. And let's start with the first one. Okay, let's look at here. As you see, there is a regular pentagon here, and we are asked to find the angle between the angle formed by AC and BD. So what I'm going to do is one of the very basic problem. So what I'm going to do is I'm going to draw the circumscribed circle of this regular pentagon. It's because, as you see, ED is equal to DC. And those are all equal because it's regular pentagon. Therefore, the arc of this length, not the length, the measure of this arc and the measure of this arc, they are all going to have the same measure, and there are 5 of them. So if I divide 360 degrees by 5, I will have 72 degrees. So 72 degrees mean BC, arc BC has 72 degrees, and DEA, arc DEA has 144 degrees. So remember from circles, how can I find the angle? Remember, I take the sum of the angles, 144 plus 72 degrees, and I take the half of it. So it is 216 over 2, so the answer must be 108. Let's look at the next one. In here, there is a regular hexagon. And one of the sides of the hexagon is 4 centimeter, and it says PB is equal to 3PA. So this is, for example, if this is 1, PB will be 3. Is this correct? Yes, because remember one of the sides is 4, so it will be divided 1 and 3 respectively. Okay, and then what I'm going to do is I'm going to draw the altitude point P to the ED. Okay, and remember, if I join the vertices E and A, so this is 4, and this is 120 degrees. And remember the property of 120, 30 degrees. 4, it will be 4 root 3. So therefore, this height must be 4 root 3. So it is 3 here, 4 root 3 here, Pythagoras theorem. So it is 9 plus 48 is equal to x squared. Right? And as you see, it is 57, and take the root of it. So it is 50 root 57. Let's look at the next one. So, okay, quadrilateral ABCD is given, and these are angle bisectors, and the angles are given as well. This is 10, this is 8, and we are trying to find the area of this shaded region. So 110, 130, sum them, it will be 240 degrees. So it means angle D plus angle A is equal to 120. Because remember, sum of interior angles of any quadrilateral is 360. So 360 minus 240 will be 120. And half of it. So the angle, this one, and some of those angles must be 60 degrees. Therefore, it means the angle here is 120 degrees. So extend it and take the altitude. As you see, it is 60 degrees. So hypotenuse is 10, this is 60 degrees, and this must be 30 degrees. Hypotenuse is 10, 30 degree will be 5, and opposite the 60 angle will be 5 root 3. So how can I find the shaded region? Base times height. Remember that? So it is 40 root 3, and half of it will be 20 root 3. Question 4. Question 4. As you see, there is a parallelogram and it says EF is parallel to AD. So EF is parallel to AD and it's a parallelogram, therefore it must be parallel to BC as well. It says these are angle bisectors. If those are angle bisectors in parallelogram, then this angle must be 90 degrees. Okay, it's 11 is 3. Okay, let me extend this parallel through AB, okay? I just extend EF through AB. So since it is 3, let's say phi G must be 8 because remember this is parallel to this one. If this length is 11, this length must be 11 as well. And this is 8 and look at here. Oh, I have alternate interior angles and again alternate interior angles. Therefore, this is an isosceles triangle and this is an isosceles triangle as well. So wow, what we got here is actually the magnificent triple. Okay, since FG is 8, AG must be 8 and GB must be 8. Okay, was asked, find AB. So AB is 16 centimeter. Let's look at question 5. Okay, some information drawn in the figure. BD is perpendicular to AD, BH is perpendicular to DC, AB is 15, HC is 3. Since it's a parallelogram, DH must be 12. And again, alternate interior angles. If this is 90 degree, this must be 90 degree. And look at that. There is an altitude coming from the perpendicular, the right angle. So I can apply Euclidean property, okay? I can apply Euclidean property here. What is the Euclidean property? The height will be equal to, so let's say this is height. So can you see that h square will be equal to 12 times 3? 12 times 3. So it's 36. So height must be 6. So we are trying to find the area of ABCD. Height is 6 and side is 15. So 6 times 15 will be 90, which is D. In this question, as you see, there are two line segment AG and EB, and they divide the sides of parallelogram into halves. So in those kind of questions, I always extend one of the line segments. In this case, I'm not going to extend it through there, but you can extend it. I hope it will be working. I'm going to extend AG through here, okay? I'm going to extend them. And look at here. The angles are alternate interior again. And those angles are the same, and these angles are the same. So I have side angle. So I have angle side angle congruency, because you see these are the same angles and this is exactly the same side for both triangles. This little one and this little one here. So since they have the same units, since they have the same length, let's say if this is A and A, so AB will be 2A and this length here will be 2A as well. So this is the congruency or similarity for point G. And let's look at point F. So again, this sandglass shape, or how do you call this shape? I don't know. We call it butterfly similarity, but I suppose you're calling it as sandglass similarity. I don't know. Okay, it's 3A here and 2A here. So the similarity is 3 over 2. And one side is 6. So this side will be, I don't know, 6 over what? So it is 12 over 3 will be 4. Okay, I found the height. And let me call AF as x. As you see, it is x plus 3. And this must be x plus 3. And again, apply the similarity for point F. It will be 3 over 2. 3 over 2, it is x plus 6. It's x plus 6 over x here. So as you see, 3x is equal to 2x plus 12. So x is 12 actually. So this is 12. It makes this side 15. So 15 times 4 will be 60. Half it will be 30, which is the area of this triangle. Okay, let's look at this one. Rhombus ABCD, AH, BH, they are equal to each other, and this is 6 root 3 and this is 4 root 3, and we are trying to find this portion here. Okay, let me do, and remember, keep in mind that this is a rhombus. Let me draw the diagonal. So this is the diagonal, and these are all equal. Okay, this is A, and this is 2A. And wow, look at what I have here. So it is A, and hypotenuse is 2A. So it means the angle here must be 30 degrees and the angle here must be 60 degrees. So it means that's actually an equilateral. So since it's 6 root 3, this must be 6 and this must be 6 and this must be 12. And again, if this is 60 degrees here, this must be 60 degrees here as well. So this is 30 degrees. What is the side opposite of 30 degrees? It will be 4 because opposite of 60 degrees is 4 root 3. So 90 degree will be 8. So remember, it's a rhombus. This must be 12. So it leaves x as 4. Question 8. Rhombus, again there is a rhombus, and equilateral triangle BEC. So BE is equal to CE is equal to DC, and these are all equal, and this side as well. So AC is given, AE is given, so this is given, this is 20, and we are trying to find again the area of this shaded region here. Okay, what came to my mind was, if this is 60 degrees, let's say this will be x. Okay, this will be x because this is an isosceles triangle. And I know this is 60 degrees. What is the exterior angle here? It will be the sum of two other interior angles, so therefore it is 2x. Okay, the angle here is 60 degrees plus 2x. Therefore, the angle here must be 60 degrees plus 2x as well. And remember, in rhombus, diagonals are perpendicular to each other and they bisect and they are angle bisector. So the angle here 60 degrees plus 2x, therefore the angle here must be 30 degrees plus x. The angle here must be 30 degrees plus x, but this is already x, so therefore this must be 30. Wow, again, look at here. I am trying to find the area of this triangle, and I know this side, which is 16, and I know this side, which is 20, so I can apply the sine formula for the area. So it is 1 over 2, it is half times 16 times 20 times sine 30. What is sine 30, guys? So it is 1 over 2. So it must be 1 over 2. This comes from sine 30, okay? So simplifications, it will be 4. 4 times 20 will be 8. So let's continue with the other page. Okay. Again, this time a deltoid given. Okay, AB is equal to AD. AB is equal to AD. Okay, then BC must be equal to CD because it's a deltoid. If two of the sides are equal, then the other two sides must be equal as well. AB is equal to AD, blah blah blah. These are all given and marked on the shape. So it is 8, it is 12, and GH is equal to HD. We are trying to find the area. Okay, remember in deltoid, the diagonals bisect each other. Let's say this one and this one. And also they are perpendicular to each other. So look at here, is it's median and it's one of the medians, so G must be the centroid of BAD triangle and H must be the centroid for BCD triangle. Therefore, remember the ratio for centroid, it is 2 and 1. So if AG is 8, G, this point must be 4, and if this is 12, this must be 6. Okay, and what else we have? So GH is 10 and GH is equal to DH. So this must be 10 as well. So 6, 10, it is 8 here. So it is 10, it is 8, base is 10, height is 8, over 2 will be 40 centimeter square. There is a parallelogram here. There is a parallelogram here. And DEE is equal to EB. EF is given, this is given, which is 10. Okay, this is given, which is 10. And FC, this is given, this is 16. Okay, let me name, this is a parallelogram, not a rhombus by the way. Let me name AD as 2A. Then BC must be 2A. FB will be 16 minus 2A. Okay, agreed? And then I am going to draw parallel from point E to line segment AF, okay? So I am going to draw parallel. This is parallel to this one, and therefore this is parallel to this one. And then this must be 90 degrees. And remember the Thales proportions. If DE is equal to EB, then let's say EP, okay, let's say AP must be equal to PF. Remember the proportions, because as you see there is a trapezoid here, and remember the proportions. This is parallel to AD and this is parallel to FC as well. And besides the portion here must be exactly the same with this portion. So if this is 2A, then this portion must be A, the half of it, because it's the mid segment of this triangle. And this is the mid segment of AFB triangle. If this is 16 minus 2A, the line segment here must be 8 minus A. Therefore, the length of PE is actually 8. Right? Because it's 8 minus A and this is A, so it makes this line segment here 8. And this is 8, this is 10, so this portion must be 6. Therefore, is equal to this portion, it must be 6, and sum of them will be 12. Okay. Here we have rectangle and a square. This is 2 unit, this is 4 unit. Okay, this is 2 unit, this is 4 unit. And again, let's say CK is 2A. Then since the ABCD is a rectangle, this will be 2A plus 4. And ET is the mid segment of this triangle. Therefore, ET will be A plus 2. So it is A plus 4 here, and it is 2A here, and it's a square. So they must be equal to each other. A plus 4 is equal to 2A, A is equal to 4. And we are trying to find the area of the rectangle. So A is 4, that makes here 12. And here is 8, so this is 8, so this is 8. And remember again the Thales proportions. So if this is 8, this must be 8 as well. So this is 16. So 16 times 12 will be 192. The following question, square ABCD, AE is equal to EB, perimeter is 96, therefore I can find one of the sides. 96 over 4 will be 24. Therefore, if I take the altitude from point to AB, As you see, it will divide 12, 12, and it will be 5 here. So it says, what's the distance between point E and the center of gravity? Center of gravity is the point where diagonals intersect. So I know it's not linear, but suppose that it's linear and the point must be somewhere here, but in order to make it appear on the shape, so I put it there somewhere here, okay? So remember, the center of gravity, centroid of the square, is the intersection point of diagonals. So it's actually, this is 45 degrees and this is 45 degrees here. So it's a right isosceles triangle. So this must be 12 as well, because this is 12. And since this is 5, this must be 7. So this is the distance we are asked to find. Okay, in the following question, let's get it. Okay. In this one, square. Again, we have a square. And it says AE is equal to DC. So AE is equal to DC. Therefore, these are all equal. Since this is 60 degrees and these are equal, so I automatically think that, let me join those vertices. And therefore, I have an equilateral triangle here. So it leaves 30 degrees here, and look at what we have here. So it is it's an isosceles triangle. It is 30 degrees, so it must be 75 degrees here and 75 degrees here. We are trying to find the measure of x, which is 135 degrees, because some of them will be 135. Okay, in the following one, again parallelogram and again half shapes. So again, in the previous question I extended, so again I'm going to extend it. It's not linear this time, but sorry guys. Okay, pretend it like it's linear. I extend it linearly, okay? It's my bad, sorry. And again, I'm going to, we just proved that those are congruent triangles, and let's say this equal to this one and this equal to this one, okay? And in a question it's given that BE is here, so it is 2 times of EC. Let's say this is 2A, and therefore BE will be 4A. It leaves FD 3A and FA 3A. Okay, fine. And HG is given, which is 10. And we are trying to find the length of AH, this one, X. So, okay, for the point H, I'm going to apply similarity, and then for point G, I'm going to apply again similarity. For point H, as you see, the ratio is 2/1. So HC over X will be equal to 2/1. So it is actually 2. So HC is equal to 2x. Okay? HC is actually equal to 2x. It means that the portion here must be 2x minus 10. And for point G, again apply similarity. It is 2/6. 2/6. So it's equal to 2x minus 10 over x plus 10. Wow. I guess I can find the value of x now. So it is 3 simplifications again. So x plus 10 will be equal to 6x minus 30. So 5x is equal to 40. X is equal to actually 8. Okay, the 15th one. Okay, DC is 5. AD is 8, AB is 12, and we are trying to again find the value of x. So let me draw the median of trapezoid. Therefore, this portion here must be equal to this portion because it's the median. So these are 4. And what is the length of median in trapezoid? It is the half of sum of upper and lower, it is the half of sum of bases, right? So this is 12, this is 5. So it will be 17/2. And it reminds me the triangle, the special triangle 8, 15 and 17, but look at it, it is 4, the half of it 4, half of it will be 7.5, half of it will be 17 over 2, so it must be 15 over 2, which is 7.5. And the last question of the first test. Trapezoid ABCD, and attention that it's an isosceles trapezoid here. So let me take the height from point C to the AB. So what will be the portion here? Remember, it is 10 minus 4 over 2, so which is 3 actually, so it is 3. And it leaves 7 here. And in the, so it is 3, it is 5, it will be 4. And in the isosceles trapezoid, how can I find the area of the trapezoid? Remember, height times this portion of the base will be the area. Or if you're not convinced, take sum of, find the median of the trapezoid, which will be 7 again, and multiply it by the height of the trapezoid, which is 4. So you will have again the same answer, 28. So thank you for paying attention this test. If you have any questions, please comment below. Thank you. See you.